Okay, good evening, everybody. Welcome to mathematics class. This evening, we are going to learn geometric progression, also known as GP. And sometimes we also call this one as a geometric sequence. So first of all, let us define what geometric progression is all about. So we define geometric progression as the sequence of numbers where each term after the first term, and now take note of this, they're saying after the first term. Okay, in geometric progression, first term is actually denoted by a small letter a, as you see there, is now found by multiplying the previous one by a fixed or non-zero number, and this non-zero number we normally call it as common ratio, and it's abbreviated by a small letter r there. So who abbreviate that one with a small letter r there? Okay, so if you look at the following examples, these are some examples of geometric progression, also known as GP. We have 2, 4, 8, 16 up to 32. So take note of this, from 2 to 4, and then 4 to 8, 8 to 16. All right, for us to get 4 here, what we are doing here, we are multiplying a certain number there to 2, which is the first one, to get this number 4. And obviously find that for us to get the 4, we are normally multiplying it by 2, which is 2 multiplied by 2. All right, so 2 multiplied by 2, we get a 4. And for us to get an 8, we are also multiplying by 4 multiplied by 2 to get it, an 8. Likewise, if we want to get a 16, we are having 8 multiplied by 2 to get a 16. So for us to get this common ratio, what we normally do is we take the next number divided by the number that comes before that number, which in this case 2. So 4 divided by 2, you get it, that 2, which is called a common ratio. Likewise here, if you want to get the very same, you take 8 multiplied by 4, should be divided by, not multiplied but divided by 8 divided by 4, which you get 2 as well. 4 divided by 2, you also get a 2 as well. 16 divided by 8, you get a 2 as well. So this common ratio is actually the same throughout. All right, and again, if you look at the next example where we have 40, then we have 20, 10, and then 5. In this case, what you notice is that you notice that for us to get a 20, we're actually dividing by 2. Right, so we are dividing here by 2. In other words, we are multiplying by half multiplied by 40 to get a 20, and again a half multiplied by 20, we are getting a 10, and again a half multiplied by 10, we still get a 5. So what we are doing here is we are taking 20 divided by 40 to get this common ratio, which is half. 10 divided by 20, we are still getting a half, which is the common ratio there. Likewise, 5 divided by 10, we are still getting a common ratio, which is half. Okay, so in general terms, whenever you have been given a geometric progression, the general form of any GP, all right, is given as AR n. That's AR to the power n minus 1. Our A stands for the first term. Our R is our common ratio. And the n is normally the number of terms in that particular sequence, or the nth term of that particular sequence. That's the value of n. For example, in this case, if we want to get 16, for example, we can still use this and we still get a 16, because our A here is going to be 2. Our R is going to be 4 divided by 2, which is 2, And then our n, we look at position where 16 is. So 16 is in position number 4. So in this case, our n is equal to 4. So simply substitute here. Where there is a here, you put a 2. Then multiply by where there is r, you put also a 2. And where there is n, you put a 4. And then minus 1. Okay. Example, you have 2 multiplied by 2, and then to the power 3 should be 4 minus 1, which at the end of the day you have now 2 multiplied by 2 to the power 3. And normally 2 to the power 3, that's 2 times 2 times 2, which is 8. And 8 times 2, this one will give you a 16, like that one. So this is the general form of any geometric progression. Alright, so let's proceed on and look at some few examples. Alright, so let's look at this example. Example number 1, which is A. Calculate the 7th term of the following GP. So we have the GP here. Our GP, as you can see from here, we have 2, then we have a 6, and then we have an 18 there. Now we have to find the term which is on position number 7, and we're calling that one as the 7th term of that particular geometric progression. So we call it as 7th term. Wow, very simple here. So what we're going to do there is quite easy. You still use the general form of geometric progression, which is AR to the power n minus 1. And where there is A, alright, where there is A, you put a 2. And where there is an R, you need to find an R. What is an R? For you to get an R, you simply take this next number, which is 6, divided by 2. We're getting a 3. Or you may say 18 divided by 6. You are still getting a 3. So our R here in this case is actually a 3. And then where there is n, alright, our n there is going to be 7. That's our n there. Our n is going to be 7. So our A is going to be 2. Our n will be 7. Then our R is going to be actually 3. Not actually 2, but it's going to be actually 3. Because we're having 2, 6, 18, stuff like that. So we're having a 3 over there. And then we need now to substitute. Where there is A, you put a 2. And where there is an R, you put a 3. So we have a 3 there. And then here you also substitute. We have a 3 there. And then you use your actually calculator. Find out what is actually 3 to the power 6. Alright, so there are several ways of solving that particular problem. Alright, so you can use your calculator there. 3 to the power 6. What do you have there if you use a calculator? Alright, so let me use my calculator here. I get what I have there to see the value that I can get from there. Alright, so that's my calculator. Got my calculator. You can get your calculator from your phone, or you can use your calculator, the one you bought, and so forth and so on. Yeah, so we have 3 to the power 6. That's what we have there. Okay. We have 3 to the power 6. Okay, so according to what I have here, 3 to the power 6, 729. Alright, so 729 multiplied by 2. Alright, multiplied by 2, what do you get? 1458. I think that's what I'm getting here. So I'm getting 1458. I think you can cross-check that one. Cross-check that one, whether it is right or not. Okay, yeah, so there are several ways of cross checking that one. Yeah, so let's try to cross check, because 3 to the power 6 3 to the power 6 is the same as 3 multiplied by 3 times 3 times 3, 6 times. So you can even cross check that. 3 times 3 times 3 times 3 times 3 times 3. Alright? About 6 times, and then multiply by 2 is to get that value again, 1458. So in this case, what are we saying? What we are saying here, according to our problem here, the seventh term of this particular sequence is going to be 1458. So let's go to the next question. The next question says the first term of a GB is 5 and the common ratio is 6. Find the third term of the sequence. This is quite very easy as well. We still need to use the general form of our geometric progression, which is AR to the power n minus 1. So according to here, our A is going to be 5. Our R is already been given there, which is 6. So using this formula here, the general form, AR to the power n minus 1, where there is n, you are supposed to put a 3 on that one. So at the end of the day, this is what you have. Okay, so we have 5 multiplied by 6 to the power 3 minus 1. And if you look at that one, we have 5 multiplied by 6 to the power 2. If you evaluate this, you get 180. So you can try to evaluate that one. So it means our third term according to this particular sequence is going to be 180. That's our answer there to this particular response. You can verify that one. Okay, next we have again another question here which says if the third term of a GB is 8 and the seventh term is 128, then find the common ratio of the sequence. Right? So in this particular case, what you're supposed to do is quite easy as well. You still need to use the general form of geometric progression, which is our GB, which is AR to the power n minus 1. Okay, you still need to use that one as well. Alright, so there are two values here. According to here, we have the third term, and then we have also the seventh term. And the seventh term here is 128, while the third term here is actually 8. So all what you need to do there is quite very simple. We're supposed to substitute. Alright, substitute, that's according to what we have here. Alright, so you're going to substitute. We have AR where there is 3 term, you put now 3 minus 1, and we have been given that it is 8. On the seventh term, we have also been given that it is 1.8. So you can see here. So it's like we have two equations. We have 3 minus 1, which is AR to the power 2, which is 8. And then we have also this, which is AR to the power 6, which is actually 128, as you see from there. So we are going to use these two equations, possibly, and we're going to divide these equations. Why are we dividing? Maybe that's the question. Normally we want to eliminate A. Well, there is an A, there is an A here. We want to eliminate that A so that we should remain with only R. So if we divide both sides, AR to the power 6, here that AR to the power 6 is 128, divided by AR to the power 2, which is 8, which is also 8 here. So this A and A will cancel. Will remain with the R to the power 6 divided by R to the power 2. According to the laws of indices, R to the power 6 and then R to the power 2. We have the same basis. Alright. Now if we have the same basis, we normally actually subtract the power. So it will be like the same base, which is R, and then we have 6 minus 2, which is 4. So we have R to the power 4, which is 16. And then from here, what we are supposed to do is actually to make sure that we simplify this 16 so that the power of this should be the same as r to the power 4. In other words, should have the power 4, like what we have here. So this is achieved by taking 2 to the power 4, because 2 times 2 times 2 times 2 4 times, we get 16. Now because the powers here are the same, like we have here power 4, and then we have also here power 4, the powers are the same. Since the powers are the same, then the bases are also supposed to be the same. That's why our r is equal to 2. Therefore, our common ratio is actually equal to 2, like that one. Now, that is why the common ratio here of the sequence is 2. To find the first term, we can use either of these two equations, ar to the power 2 equals 8, or ar to the power 6 equals 1.8. But we're going to use this simpler one, because we have ar to the power 2 equals 8. So where there is a, we still we say d, we don't know. That's what we want to find. But now where there is r, we have already calculated r. R is equal to 2, and then to the power 2 equals 8. We have taken the first equation. So this is 2 times 2, 4, 4 times a, that's 4a equals 8. So here, to find the value of a, you simply divide both sides by 4, and then we get a 2 as our response there. So according to this question, the first term of the sequence there is supposed to be actually, the first term there is supposed to be actually a 2 over there. So yes, so as of now, let's stop there. If you have got questions, please ask. Where you have not understood, you're most welcome. As of now, I'm going to post an assignment on the very same page. So after you have actually finished looking at these problems I have given here in this lesson, please go and try the assignment that I'm going to give you later after this lesson. Thank you very much.